Hey, Mr. Herdum here, and hey,
Hi.
fourth period's here too again. Watch me do another video, because I don't have time to make videos except during class apparently. This unit, just so you know. When will solutions conduct electricity? An electrolyte is a substance when dissolved in water has a dissociation and gives a solution of ions, which has the ability to conduct electricity. Electrical conduction requires a pathway for movement. Yeah, you have to have movement of electrons. That means that you need to have charged particles that can move. That means it has to be soluble, ionic, soluble acid, which all acids are soluble, or soluble base. Those are the three things that are electrolytes: soluble ionic, soluble acid, and soluble base. Let's go on to page 9. Page 9! Okay. Do. Soluble ionic compounds are strong electrolytes when they are dissociated. They conduct electricity very well because they dissociate 100%. If they dissociate 100%, it will be strong. Strong acids and bases are strong electrolytes because they conduct electricity very well because they dissociate 100%. So they conduct electricity. Weak acids and bases are weak electrolytes, which means they conduct electricity but poorly because they only partially dissociate. Back from our other notes here, remember that if it partially dissociates, it goes forwards and backwards. It's an equilibrium. If it 100% dissociates, it only goes forwards. And if it 100% dissociates, it only goes forwards. Okay, melted ionic, which are ionic substances that were melted. They're heated up to like 1,000 degrees to melt them. And metals, like copper for instance, do conduct electricity, but they're not dissolved. So they are not considered electrolytes technically. Covalents, nobody likes covalents. They are never electrolytes. Some may dissolve. Remember, the polar ones dissolve. But they don't form ions. They are not electrolytes. Insoluble ionic compounds never conduct electricity. They are never electrolytes. They don't dissolve, and they do not form ions because there is no movement of ions in these. Yeah, I can hear Miss Kokarni across the wall. That's pretty cool. Maybe she's teaching the same thing I am. Oh, email. No. Okay, go away. Okay, thanks. Now, tap water will conduct electricity while distilled water doesn't. Propose an explanation for this difference. Well, here's the thing. Tap water has dissolved ions. Like fluorine, like calcium, like iron. They are in the water, which means this will conduct electricity. Meanwhile, distilled water has these ions filtered out. They run them through these big ion exchange columns and they take out all the ions in the water, which means they don't conduct electricity. Example 12.12. Fill in the following chart. Oh, what fun! Okay. Remember, we are trying to figure out if they're electrolytes. If they are electrolytes, it has to be soluble ionic, soluble base, or soluble acid. Those are all electrolytes. And I wrote that down, and it's not on the screen. Awesome. That's what makes me a great teacher. Write that down because I want you to write that down because I wrote it down. Soluble ionic, soluble base, soluble acid. They are all electrolytes. Okay? Probably my face is covering it too. It happens. Phosphorus tribromide. Phosphorus tribromide is PBr3. This is a covalent substance. It is a polar covalent substance, so it is soluble. But since it is covalent, it is a non-electrolyte. Because no covalent substances are electrolytes. Methane, remember the formula for that is CH4. This is also covalent because it has two nonmetals. This one is not soluble because it is nonpolar, and that would not be soluble in water. So this is also a non-electrolyte. Acetic acid. This is an acid because it says acid. This is the acid of acetate. You remember acetate's my favorite polyatomic ion of them all. C2H3O2 minus, and acid starts with H plus. So this is HC2H3O2 minus. Since it's an acid, we all know that acids are all aqueous, so we always put the AQ after it. So this is soluble, yes. Is this on the strong acid list? It is not. This is a weak acid. So this is a weak electrolyte. Hydrochloric acid. This is the acid of chloride. So this is just H plus Cl minus. Hey, the next chapter is acids and bases. We get to study that next. Awesome. Hydrochloric acid is an acid. It is on the strong acid list. It is in your stomach. Remember that is gastric acid. It is soluble. And since this is a strong acid, this is a strong electrolyte. Then we get to the fun ones here. Copper 2 sulfide. Copper is Cu. Sulfide is SO3. Remember, sulfate is SO4 minus 2. Subtract an oxygen for the sulfide, so it's SO3. This is minus 2 and this is plus 2. This is CuSO3. This is ionic because it has a metal in it. Now we have to look at our rules. Here, rules. Come out wherever you are. Okay. Copper sulfide. Copper is not group 1, not ammonium, not nitrate, chlorate, perchlorate, or acetate, not chloride, bromide, or iodide, fluoride, sulfate, that's sulfate, not sulfite. SO3, OH minus. So we fall into this last rule here. So CuSO3 goes into this last rule here, which means it is solid, which means it is not soluble. Since this is not soluble, this is a non-electrolyte. So it has to be soluble to be an electrolyte, and it has to be ionic, acid, base, or ionic. Last one here, ammonium carbonate. Ammonium is NH4+. Carbonate is CO3 minus 2. Plus 1 and minus 2, so this is NH4, 2, CO3. We go back to our solubility rules again because this is ionic, don't you think? It is like rain on your wedding day. It's like a free ride, but you've already paid. Okay. Back to ammonium here. Carbonate. Group 1, no. Ammonium, right here. So ammonium carbonate stays in this square right here because there's no exceptions. So this is AQ, since it's in the first square. So this is soluble, which means this is a strong electrolyte. What you guys in fourth period think about that one?
Awesome.
You think that was awesome?
Yeah.
I do too. Because I am a legend, you know. Okay? And you guys are still champions, especially fourth period.
You're the best.
Okay? Legend is out.